Class, you should have watched the first video, Open Inquiry, answering the two hypotheses that we came up with the pendulum. Um, think about the advantages of that teaching method. You should have also gone to discussion board and put your answer as to whether increasing string length causes the rate to increase, decrease, or stay the same. Then you also need to go answer whether increasing weight causes the rate to increase, decrease, or stay the same. So that would be open inquiry. Basically, I give you a starting problem and I leave it up to you to find the answer. Guided discovery is a little different approach. It's more teacher direct. So what I'm going to basically do is tell you how to do this experiment. If you don't have washers, you can use the little nuts that go with a bolt. Like I said, I've seen people use bagels, but anything you can suspend from a string is basically what you would use to do a pendulum. I'm going to teach it the way I do it in class normally. Hopefully you have these materials, but if not, you can improvise. Take a paper clip. I like to use a paper clip. Tie your string onto one end of the paper clip. Like this. I've got 3 washers, but I'm just going to use one right now. Hang the washer on the paper clip, and basically you have your pendulum. And I always like to, talk about pendulums a little bit. Tell the class they're getting sleepy as they see it go back and forth. A pendulum is a weight suspended from a cord, string, something from a fulcrum, or my hand in this case is a fulcrum. I always ask, where do you see pendulums? And I know just about every possibility. The grandfather clocks has a pendulum in there. Grandmother clocks have a pendulum. A swing on a swing set is a pendulum. The wrecking ball that they use, I don't know if they use wrecking balls anymore. Miley Cyrus uses a wrecking ball, but other than her, wrecking ball, my wife's shaking her head over that. Wrecking balls were at one time used to knock down buildings. Other places you may see pendulums, I can't really think of too many offhand. You get a little pendulum action with the tether ball. If you ever get a chance, go look up the video on, it's a French word. I can't remember how it's spelled. But it's a pendulum that is hung on a string that is so long that it actually moves by the Earth's rotation. It goes back and forth on its own. It's a French word. I can't remember it. You can find one at the Smithsonian Institution. I think there's one in Dallas, Texas, and I've seen one in Portland, Oregon. I always do like to talk about The Pit and the Pendulum, the old Edgar Allan Poe short story. The boys seem to like the story. Basically, it was a torture device in the short story that it was basically a blade was the weight. And each time the pendulum did it, what's called the period of the pendulum, it would drop like an inch, and then it eventually cut some guy in half that was strapped to a table. A little gore there. So, give you a little background on pendulums. Now we're going to try this as an experiment, and what I want you to do is draw you... Well, here's more information. So we're looking to see if the pendulum is going to change if you increase the string length. You got 3 choices. Same for the weight. You increase the weight. You got 3 choices. It's going to go faster, slower, or stay the same. But what you need to do now is to draw you a table like this. We've actually got the table for 2 different experiments here. This first one is we're changing the string length, and we're going to try 20 centimeter length, 40 centimeter length, 60 centimeter length. If you don't know what a centimeter is, it's about the width of your little finger. About 2.5 of those make an inch. I always like to ask the students, why are we going to do 3 trials? By doing multiple trials, you eliminate error. One thing I think that's important as a teacher to think about is if the kids are doing their measurements and they get numbers like this, 10, 10, 15, then you get the average. What should you tell your students to do if they get a number like this that doesn't match up? Something went wrong in their test and measurement. I would tell them to do a fourth trial. I hate doing tables where it locks you in and you don't think outside of the table. So if the numbers look funny, I always tell kids they need to do it again. So after you get your average, maybe it'll be something nice like that. The average swings, and we're going to do it for 15 seconds. We're going to count 15 seconds. The average swings would be 10. So how do you get swings per minute if we count for 15 seconds? You multiply it times 4 because there's 4 15s in a 60 seconds. So the swings per minute could be something like that, 40 at 20 centimeters. And I made those numbers up, so that's not necessarily what you're going to get. The really important thing you got to think about to be a good scientist, you got to think about controls. First, I want you to recognize your variable. The manipulated, which in some high school books is called independent, is your string length. That's what we're changing. That's what we're manipulating. The responding is the swings per minute. That's what you're going to be counting. You're actually going to be counting for swings per 15 seconds so that you can do this in a reasonable amount of time. Your controls. I always say perhaps a drop point of 45 degrees. Basically, you bring it up from the tabletop and drop it 45 degrees. And I'll show you what I mean here in a second. The weight for this is always going to be one washer. You're not going to add washers. The force, the easiest thing is let gravity do this. That way you take the human error out of it. You just drop it each time. So to set this up, I'm going to come back to this other table here in a second. To set this up, this is my one joke of the semester when students had textbooks, but now that you don't have a textbook, I can't make that joke anymore. You get to use your laptop though. Basically, if you have a laptop, you can rather than having different length strings, you can just put a mark on your string. And I don't have a ruler handy, but you would pull it up to the 20 centimeter mark. You can close it up, and that'll tie it close. And now I've had students actually draw a protractor underneath so that they can always bring it back 45 degrees. So you can do it however you want to, but that helps your accuracy if you have a protractor under here to watch how far up you bring it. So you let go, and you count when it comes back. So that's 2, 3, 4, 5, 6, 7, 8, 9. You need somebody with a stopwatch that can help you time over 15 seconds. So back and forth is 1. That's how you count. That's the period of the pendulum. So 1, 2, 3, 4. That counts. You count over 15 seconds. So you change your string length by using your computer. 20, 40, 60 centimeters is your lengths we're going to try. That's your first experiment. You're going to do 3 trials of each one of those. So let's go back to the table here. After you get your data, forget everything. We're now going to look at weight. So it's 2 separate experiments. A lot of times students will try to do them both at the same time. Well, you can't. You've got to manipulate one thing and then control everything else. So basically what I want you to do now is try, if you have washers, 1 washer, 2 washers, 3 washers, 3 trials, swings per 15 seconds, get your average, multiply it times 4, put in your data there. I'm going to save you some time. Weight's what we're manipulating. Responding is the same thing as for the changing the string length, swings per minute. The control, same drop point, 45 degrees is what we'll use. What I want you to do for your control, you got to keep the string length the same. So you can actually take this data right here for 1 washer and you can put it right there. It's the same thing. So, and then you'll just drop it each time. Then you'll have to do it for 2 washers, and you'll have to record your data on these. And all I can say is if you're not convinced of anything, you could make your string length shorter than 20, longer than 60. You could do 5, 6, 7, 8 washers. Just be willing to go outside of the table to convince yourself of your results. As far as graphing goes, let me show you that real quick. You do need to graph your data because a graph can help you go outside your data to make a statement. So I'm not drawing your graph for you, but I want to show you how you set it up. Your manipulated variable goes on the x-axis. Your responding variable goes on the y-axis, and that just helps see what's going on better. I don't know if it's by convention, but if you're doing a science fair project with data and you're doing a line graph, that's how you would do it. This is a line graph setup. So I've basically changed the washers, and I have swings per minute in the y column, swings per minute in the y column. This is changing the string length. So you do have to graph your data, and all this needs to be submitted, and I think it's under assignment 8. Assignment 9 asks you to compare and contrast the 2 teaching methods of guided discovery and open inquiry, but it's described in the assignment. Feel free to email me if you have any questions. Thank you.